Alright, so after you guys left, I went through the lab and I did it again. I did not do the first one because you guys did a lot of good data on that. I told you that this was going to be the first lab that you had to do by yourself, like when you get to college. And you saw how chaotic it was and how you were so confused is because a lot of you, which I told you could, which was shrink this down or ask me to and glue it in there. It doesn't mean that you don't have to read through it like you would when you're writing it down. While I know I don't expect you to know exactly what to do in the lab, that's why you're taking AP Biology. That way, when you get to those 3-hour labs in college, you're able to understand what is expected from you, and you have experience doing the lab on your own. So all these labs from here on out will be on your own, and you would not be as confused if you did the work like you were supposed to in the beginning. And then you would know exactly what questions to ask. While you guys wanted me to write this up on the board because it was simplified, you can do that as well whenever you write your procedures out. And you can look up labs like this to see what it looks like before you do it. Like you can YouTube it, the decomposition of hydrogen peroxide by catalase, and you can see a lab that was very similar to this, if not the same one. You can probably find that like teachers like I do for you, like during COVID and stuff. While I feel bad that you guys don't have the lab experience you need, also you got to do your work on the front end, because in college, they don't care. They put all the stuff up like I did, and the professor works on his own lab that he's researching. They don't help you, or she doesn't help you. So the first one, you guys actually got really good data. It wasn't as overwhelming. You were able to follow the directions really well. And so I had high hopes that we could do part 2 and 3 together. Part 3 was a lot easier. Part 2 was going to take the majority of it. But in general, this lab should not have taken 90 minutes. We should have had time to do extra practice at the end of the class, and you saw that that was not the case at all. You didn't finish part 2 by the time. So when you left, I redid the lab. I will tell you that there is going to be some experimental error you will see because we don't have the supplies at Peach County High School. We should be able to do this lab. We made it possible, and I got some decent data, but it can be more accurate, just so you know, for your formal lab report. There are things called water baths that they all have. It's in the same thing, and it's accurate temperature. Like I was telling you today, that the hot plate is not accurate at all. Even if it says the temperature, that's normally not the case, and you saw that. That's why you have so many thermometers. So in part 2, I set up water baths, same thing, 5 degrees Celsius, 20 degrees Celsius, 40 degrees Celsius, 60 degrees Celsius. And I had a couple students stay behind, so I did it pretty quickly because I had them hold stuff in different places, which is another reason why you guys didn't finish, because you're in groups of 4 and only 2 people are doing what they should. When they were working on one, the other 2 people could have been working on the next temperature. And you guys will learn that because you're with the same lab group every single time, because that's what you choose to do, that's what you'll choose in college. When you show up to the lab the first day of college for that class, you don't know anyone in that class, and you've got to find buddies, and you stick with them throughout the lab. So we got to get to the point where I love that someone at the lab is taking control. That's normally how it goes, but all of you have to participate. That way you can finish in time. Because this is a formal lab report, and like I told you, you're still going to have to do it because you have all weekend. This is the best one to do because you have time to work on it when that's 45% of your grade. So I put them through the ice bath and the room temperature bath and the 2 hot baths. And I did the same steps as you. So the first thing that I did was I cut up the potatoes, got 5 grains of potatoes. I put them in little piles. I got my 2 milliliters of hydrogen peroxide. I put it inside of a beaker, not a beaker, a test tube, and I put that into the boiling water. I let that sit there. It was about 60 seconds to a minute and a half, I would say. Once that was in there, I took the graduated cylinder. I put my distilled water in there, and I put my 1 drop of soap. And I stirred it together a little bit, and I put my potatoes in there. A lot of you did not cut your potatoes to fit the graduated cylinder, which also affects your data. Because this lab, the point of it was to see the enzymes in the potato break down the hydrogen peroxide. So catalase is the enzyme that breaks down hydrogen peroxide into oxygen gas and water. So if you have my biology class, we did the liver enzyme lab, where we saw the liver enzymes break down hydrogen peroxide to water and oxygen gas. So the oxygen gas comes up out of the test tube or out of the graduated cylinder. It's up in the air, and then the water is what's left in there. The reaction and the process creates the bubbles, which is what we are measuring. So I put the 5 grams of potato in there with the dish soap and the distilled water. Then I put that into, I took out the hydrogen peroxide out of the boiling water at that point. Rocco was holding that stuff in there for me. And I put both of them directly into the 5 degrees Celsius water, which was ice water. My ice water did not get as cold or stay as cold as long. It was up to the temperature during the lab, but it did eventually come out of it. So I put them in there for, it probably took me about 3 minutes to get it down to the temperature, which is what the lab told you, 3 minutes or until it got to that temperature. And then when I pulled it out, I poured my hydrogen peroxide into the graduated cylinder, and I looked at the initial volume. All my initial volumes were 28 because I measured it correctly. A lot of you were not being accurate with the hydrogen peroxide, and you were holding up the graduated cylinder and reading it like this. You know that graduated cylinders have meniscus. You need to put it on a flat surface and get to it like eye level. So your data was messed up once again because of experimental error. So then I poured the hydrogen peroxide in there, got the initial volume. Then I took the graduated cylinder and I put it back into the ice bath for 2 minutes. Once the 2 minutes was up, I took it out and I read the final volume. So I figured out why. I was like, why does this lab keep saying do initial minus final? It's the verbiage of it, and not even I caught it because I was not reading it like I should. It says to take the, where's it at? It says to subtract the initial volume from the final. So that would be final minus initial, because the change of the volume, so our little delta, change of the volume is always final minus initial. We don't want a negative number, we want positive. If you did initial minus final, you always put the absolute values around it. So regardless if you did it, it's still the same number, you just need to take that negative out by doing absolute values. So we did final minus initial, and we got that the foam generated in it, which was going to be equivalent to the reaction rate, was 2 centimeters cubed for the first one. That was the ice bath. Then we went down to went up to 20 degrees Celsius, which is about room temperature. The foam generated, the reaction rate, was about 5 centimeters cubed. The 40 degrees Celsius, so warm water, was 3 centimeters cubed, and then the 60 degrees Celsius was 0 centimeters cubed. It was pretty much denatured. So remember, we're talking about enzymes here. So on the first one, we are looking at effects of substrate concentration. So at some point, the reaction, if I were to graph this again, I would go from a low concentration of H2O2 to a high concentration of H2O2. So I would actually flip this graph around. I highly suggest that you do this on your lab report because it's going to make more sense to analyze. Sorry about that, it got cut off. But I wanted to do a long video because I want you guys to know exactly what to do for this. So once again, if I were to redo this, I would go from 0% to 0.375 to 1.5, or 0.75 to 1.5, or 1.5 to 3%. Lord have mercy, it's the end of the day. I'm ready to go. Okay, so just doing it opposite that way, instead of it decreasing over time, over the substrate concentration, it increases. And that's just because I started at 3%. So really, this is not the best because you always want to go from least to greatest. But I was going from least amount of water. So not very good, but it's okay. So once again, as the substrate concentration increased, so did the rate of the reaction, because the more substrates that enzymes had to break down, the higher the reaction rate, which makes sense because the more substrates there are, the more enzymes can keep going and reacting. If there's only a little bit of substrates, the other enzymes are just sitting there like, what do? There's nothing for me to do. There's nothing for me to break down right now. Okay, then the next data table, we did temperature, which is what I just explained. So remember, enzymes have optimal temperature ranges, right? It depends where out in the body or what organism it is, or, just like pHs, it has optimal pH range. So for our body, if this enzyme was in our body, we know that our body likes about 97 degrees Fahrenheit. So this optimal temperature range would be at the peak of the graph. So whenever the reaction rate was at its highest. So if we look, the reaction rate was at the highest at 20 degrees Celsius. So at 20 degrees Celsius, which was about room temperature, which is where potatoes like to be. That's why you don't put potatoes in the refrigerator. The potatoes at 20 degrees Celsius had the best reaction rate. That's its optimal temperature range. Outside of this range, the enzyme starts to become less active, and then eventually, like when it entered that 60 degrees or 140 degrees Fahrenheit temperature, the enzyme became denatured. It's not active. It could not react. Okay, when it was cold, it wasn't cold enough where the enzyme was not reacting. It still had a little bit of a reaction, but it did not react as fast. Just like at 40, it was hot, but it still had a little bit of activity, but this was its optimal range. So that was temperature versus catalase activity. Then for the last one, this was looking at the surface area. So enzymes are really small, and it looked at how it could react versus the substrate concentration based on its size. So I did this graph the right way. So remember, you want to go from least to greatest. So this one's opposite. It's okay. It still reads if you are able to read it. But to make more sense, it would be like this. So you go from the smallest to the largest. Okay, smallest to the largest. And you see the smallest cube size had the best reaction rate. Well, it is time for me to go. The lights just turned off. Then, as the cube size was bigger, the reaction rate decreased. So
Brooke Martin, please report to the main office. Brooke Martin, please report to the main office.
Now I'm getting called to the office. As the cube size increased, the reaction rate decreased. There wasn't as much bubbles. So that would be a really good way to research and get your cited resources about why did it not react as good. So that is my data. At the end of the video, after I show you me doing it, I took a picture of this that you can pause the video and look at it. Feel free to use my data for this one. I know that a lot of you did not do it correctly and rushed through it, and I hate that, but we're going to get better. Remember, it's just the beginning of Unit 3. My goal is that you learn something and you grow. You're going to get better. Email me over the weekend if you have any questions. They go straight to my cell phone. Text me on my Google phone. Text me on Remind. Okay? You still have to do this lab report. You still have to have good data. That's why I did it for you. Because if you try, I'm going to do whatever I can to make you grow and be better. Okay? All right. Have a good long weekend. Email me with questions. And enjoy watching this video of Rocco holding all of my stuff. Thank you, Rocco. Is it on? Yeah, it's going. Alright, so I just heated my hydrogen peroxide in boiling water, and I took my 5 grams of potatoes and put it inside my soap and distilled water solution. I'm going to leave this in here until the test tube and the beaker, graduated cylinder, get down to 5 degrees Celsius. My temperature on the water is right now is at 5.7 degrees Celsius. So in a true lab, we want to make sure that the thermometer does not touch the sides of the graduated cylinder because it will affect our data. We got to get this down to 5 degrees Celsius and 41 degrees Fahrenheit. I'll come back once it's there. Alright, so I took out my hydrogen peroxide from the ice bath, which was 5 degrees Celsius, and I took out my graduated cylinder. I poured the hydrogen peroxide into the graduated cylinder, and I'm sticking it back into the 5 degrees Celsius ice water for 2 minutes. While I did that, I heated up my hydrogen peroxide, and I put the graduated cylinder with soap and potato and water into my 20 degrees Celsius bath, which is approximately 68 degrees Fahrenheit. I'm going to leave this in here until my graduated cylinder gets up to 20 degrees Celsius or gets down to 20 degrees Celsius, and then I will repeat the process and come back.
Because we probably need to
I
get
think I might want to have some of those.
Ready?
things.
I started.
Okay. All right. So my initial was 5 degrees Celsius was 28 milliliters. When I took this out, I saw that with my foam, it raised to approximately 30 milliliters. So that was my 5 degrees Celsius, and I'll share this data table at the end. Then my 20 degrees Celsius initial was 28 milliliters, and once I took it out after 2 minutes, it was at 31 milliliters. Right now we are working on the 40 degrees Celsius and the 60 degrees Celsius. We'll come back with that data. All right, so after doing 40 degrees Celsius and 60 degrees Celsius, my still initial was 28 milliliters. I think the reason why a lot of your data, your initial measurement was off was because you were not accurate with 2 milliliters of only hydrogen peroxide. So when we went for the final, we got 5 degrees Celsius ended, the final volume was 30. 20 degrees Celsius, the final volume was 33. 40 degrees Celsius, the final was 31. And 60 degrees Celsius, the final was 28. The only experimental error that I developed was that the ice did melt, which decreased the water temperature towards the end of 5 degrees Celsius. But I'll come back and explain it all and give you a data table. All right, now we're going on to part 3. So I have 4 graduated cylinders. We filled them up to 10 milliliters of hydrogen peroxide into each of them. Then I put 2 drops of soap into each graduated cylinder and stirred it gently. What I'm doing now is I have approximately 1 centimeter cube, and I'm leaving 1 full. The second one I'm cutting in half. The third one I'm going to cut into 4s. And the fourth one, I'm going to cut into little itty bitty chopped pieces the best I can. So, come closer. The first one is full. The second one is cut in half. The third one is cut into 4s. And the last one I cut into little tiny cubes, the best I could. So I'm going to put each of these into each of the graduated cylinders. I'm going to measure the initial volume by reading it. I'm going to record that into my initial volume. Then I'm going to set a timer for 5 minutes. And after 5 minutes, I'm going to see what my final volume was, and I'll come back. Good? Mm-hmm. All right. So this is the final result. This was the full 1 centimeter cube. That has went up to 19 milliliters. The second one is the one cut in half. This has went up to 21 milliliters. The third one was the one cut in 4s. That has went up to 23 milliliters. And the fourth one was the one cut in very small pieces. This went up to 27. If you come closer, we got really good data on this. This was awesome. Versus the part 2 have a little bit of experimental error due to the BAS not being accurate due to our lack of resources here at Peach County High School. I will post the data table and do a conclusion with you guys to summarize it. That way it helps you in your lab report.